Buddy, this is group 3, and I'm going to be demonstrating our project. Our assignment was to create an Android application that would use geolocation of your phone to automatically find the weather. And every time your location would change, the application would automatically detect the change and fetch the data for the appropriate location. The second part of the project was to have the user manually enter location and fetch the information for that particular location. So in this first part, I'm going to demonstrate our application. As you can see on the screen, this is an Android application. It's running in my emulator, so I am able to supply it different coordinates, anything I wish. So to prove that this works, I'm going to give it, say, 50. And this is a location, Chibowagamu. I'm not sure where that is, but what is happening under the hood is that the system listens for the events coming from the device itself, in this case, location change. Anytime that happens, the application receives the longitude-latitude coordinates, goes to a special backend API, and retrieves the weather for that particular location. So this is requirement number 1. The second requirement was to have the user enter any particular city, and the system should be able to use that location, the name of the city, to retrieve the weather for that particular location. So in this case, we click on this little arrow. It will send you to our very basic UI. We aim to be very simple, very easy to use. And let's say we enter the city of Bridgewater. And as you can see, in this case, this is actually a different API call. In this case, we used the location city to resolve it. First, we had to resolve it to longitude, latitude, and then the API, we would supply the same parameters to retrieve the weather. The application is straightforward, very basic. It shows you the degrees in Celsius. It also has this neat little conditional statement that displays what type of weather it is, either sunny or stormy or snow. And so in the next part, I'm going to show you how we developed this and some of the basic functionalities that went into this video. Okay, we're going to start off our overview of the application with the weather controller layout. This is the main layout that is loaded when the application starts. It's a fairly basic layout. It has an image view for the image that is displayed based on the certain conditions of the weather. It has text views for the temperature and a temporary text view for displaying the current status or the current location and the fetching status while the location is being fetched. It also has this little spinner that is displayed while the API request is pending. And then the only thing else it has is the button that lets you navigate to the next layout, which we'll look at next. The next layout is just a basic input box, text box with a label that prompts the user to enter a city, as well as a back button. So this layout is very basic. Its only purpose is to have the user enter location they wish to get the weather data for, and then proceed further. Next, we're going to look at the last controller of the application, and this is the Change City controller. This is very basic. It only lets the user type in the city name that they wish to retrieve the information from. It consumes that data, stores in a variable, and then it creates an intent, which is a transition between this controller and the previous weather controller that is responsible for fetching and displaying all of the data for application. So in this case, we do the following. We get the values from the string field, which is the value that the user typed in. We create a new intent object, telling it that we're going to transition between the current class and into the next class. And along with the intent, we actually supply extra parameters. So in this case, we actually supply the name of the new city that we want the data for, and then we start the intent. And then we close down this screen completely and transition back to the previous screen, which then calls the method we discussed. So it calls this method here, which is responsible for getting the data for a particular city. That this is not getting data for longitude, latitude. This is actually getting data for a city, which sends just a query string name to the backend API, and the API is responsible for resolving that city name to the proper longitude, latitude positions, and then fetching the weather data for that particular location. The next thing we're going to look at are the metadata for the application. These are type of configuration values that are used throughout the application, that are reused throughout the application. They include the color palette. So our application uses a very basic material design pattern. It's a theme kind of guideline supplied by Google, and so they pick a standard set of colors and they just kind of reuse those colors throughout the application. So what we did is we created a resource file called color, and we give it symbolic names, so primary, primary dark, and we assign to those names values, actual color values that the computer understands and is able to draw. In this way, all of the colors that are used in the application are stored in a central location, so that if we ever want to change the color primary to a different color, we would just go to this single location, change it, and everywhere in the application that this color is used, it would be updated automatically. The same thing goes for values like the strings. These values are used in the application to inform the user, ask them to enter a city, to change the city. So these are basic values that are not necessarily changing, but more of labels, more of static text that is going to be part of the application for the life of the application. The next part of the core functionality application is the controllers and the model. We'll look at the model. This is a very basic model to store and represent the weather data. This follows the factory pattern. What that means is that this class has a static method that accepts a JSON object, data of type JSON object, extracts the values that are needed, in this case the name, city name, the condition, makes various conversions based on Celsius and Fahrenheit values, and returns an object of type weather data model. This, like I said, is a very basic class. It's very basic functionality, which is essentially just storing the temperature, storing the city, deciding what icon to display, and storing the condition. Our particular API returns a condition value that is a numeric value from 0 to 1,000, and a range of numbers within that range, sub-range, determines what type of weather it is. So here we have a chain of if-else conditional statements that check those ranges, and based on those conditions returns the name of the icon that is to be used to display on the main page. So if you can see, Thunderstorm 1 is represented from 300 to 500. This condition is actually specific to the API. So in this case, this class would only work for this particular API that returns relevant condition data, and that condition data is significant because it represents the actual weather condition. The last part of this object is just basic setter and getter methods. So the benefit of storing all this in the model is that this model contains the logic that is needed by the application, and the application is able to pass around this object to other methods, classes, and they're able to pull out data or set various types of data in this object. Now we'll have a look at the weather controller. This is the controller that is responsible for drawing the main screen of the application. This is the screen you see as the application opens with the weather, the temperature number, and the icon and the spinner. So we have basic properties or some parameters that are required by the API, in this case the API key. Our particular API requires you to register, and they generate a key for you. This way they can keep track of the requests that you make, the number of requests, the type of requests. You're able to subscribe to a better service to get more data, but that comes with a limit. So this is for them to kind of keep track of who's using it, how often they're using it. This is the weather URL. So this is the URL that our API has to call in order to receive the data. We also have time between location updates. Now this is very important because you don't want your phone constantly polling for location changes. That would make it very inefficient. It would make your application slow. It would use up phone battery even faster because it would constantly be checking. Since you don't need to be checking all the time, we have a timeout of 5 seconds. We also have a distance limitation. In this case, the distance limitation is 100 meters or 1,000 meters. This way, you're not actively calling the API every time you take, 10 feet. You don't step 10 steps forward, 10 steps backwards, because it's irrelevant. If you're getting weather data for your town, it doesn't really make sense to kind of get the weather data every time you move 10 feet. We have other various objects that are required, like the GPS provider for the location manager. We instantiate the variables for all of our view controls. That way we're able to pull the data out, update it with the new data. So this is the basic onCreate lifecycle method of the Android class. So the system essentially has various stages that it goes through, and based on those stages, the context of the Android operating system calls various internal methods of your application. So when the application starts, the onCreate method is automatically called. So this method finds all your view controls and kind of stores them in memory. So we use them later as the application keeps doing what it's designed to do. This is the onResume. This is a method that is called when your application essentially resumes. This is called when your application is rotated. So when you rotate your phone horizontally or vertically and it redraws itself, the state of the application is saved and then it's redrawn. So you have the opportunity to actually display a different screen with different values based on the orientation of your phone. Also, as you minimize your application on your phone and you come back, this application lets you rebuild the state of the application. So this is a helper method, get weather for new city, which is called whenever you transition from the next screen that we're going to look at next. This takes as a query parameter the name of the city and the API key, and then issues a weather request to the API to get the particular weather for that city. This next method is focused around getting the latitude, longitude values of your phone and making an API call for the same weather data but using different parameters. So this is a location listener, which means that you essentially tell your phone to monitor your location changes, and every time there's a change, it will call a function. This lets your application supply the function that it's going to call whenever a change occurs. And what you do with that data is entirely up to you. In our case, we have a location object that the GPS inside your phone builds and provides to our function, from which we actually pull out the data that we need. In this case, the longitude and latitude. And also we add the API key for API, and we call our getWeatherData function, which is our generic function that will actually make the API call to the server. Our next important piece of code is onRequest permission result. This is important because Android systems are very restrictive in terms of what functionalities of the phone that you get to use. Um, and this is good. Your phone should restrict access to the applications requesting access, because if this wasn't the case, then any malicious user could actually write a lot of different applications that use various core functionalities of your phone, like your location service, and send that data back to someone you may not want to have your location data. So this will actually request data from your phone, and your phone has built-in methods that will notify you and ask you permission to allow this particular application to access your location data, your contacts, your pictures. In this case, it's only location data. But this is what you would normally do for any other application if you wanted to access contacts, phone numbers, things along those lines. And this is the core method of the application that does the API call. Our API accepts a string of parameters, and based on the parameters that are supplied, it either looks up the city first and gets the longitude latitude, or if we already supply it the longitude latitude, it simply returns the weather data for that particular location. So we have the onSuccess handler, which means that if my API call is successful, this function is called, in which case we have the JSON response, and this JSON response is actually supplied to the weather data model that we've looked at previously. And from that data, we actually get a usable weather data model that we can pass around, we can update, we can read data from, write data to. And then, so this method concludes by sending that weather data model to our update UI method. The update UI method retrieves or receives this data model, which is like a box with information in it, and pulls out of that box the information that we need to display. So in this case, we display the temperature label, we display the city name, and the actual numerical value with the icon. The onFailure method is called if your API result fails. This could happen for a number of various reasons. Your network goes down, the server goes down, you're unauthorized, you may have made too many requests based on your account. So any of those issues would have to be resolved here. In our case, we went with a very basic handler code, in which case it just displays that something has failed and the actual error message that is supplied by the API. And then lastly is the onPause method, in which case this is the method that is called by the operating system based on various conditions of the system that tells your application that I'm about to pause you. You need to take care of any state management, save any data, store any data, make any additional calls, and be ready to kind of essentially go to sleep. The last thing we're going to look at is the Android manifest. This is basically the controlling file for your application. It tells the Android operating system what to do or what to expect from your application. So essentially it tells you the package of the application, package name, version, as well as what permissions the application will require. So this is very important, as forgetting to include these in the newer versions will not let your application access to the network, as well as the final location of your device. Device has many permissions. You normally would have to set these for every single internal function that you need for your phone, and even those have fine-grained permissions, which you can kind of drill down and pick and choose what you need. The other part of the application is the activities. So we have our main activity with the intent filter. This means that the application is going to launch this as the main application. This functions essentially the same way as the main function of any Java application, which is the entry point for the application. So we're telling the system to use that particular weather controller as the main file to launch whenever the application starts. And this is the second activity, which is simply the change city controller, which lets us navigate get the city name, and then navigate back so our main controller can, use the data that's supplied by the user. I hope this was an informative video. This was a very basic application. It was meant to be kind of a starting point for essentially adding additional functionality. We tried to follow very popular and known development principles by Google, by using their material design. We try to use the drive principle, the model view controller, which is essentially kind of imposed by the Android operating system and is the standard way to develop applications, which is a very good way to separate your concerns between models, views, and controllers so that individual developers, teams can work on different parts of the application. I hope that you've learned a lot from this, and I hope that you enjoy the application. We will supply the source code as part of this package. Thank you very much.